is Layla Melgosa doing mission report 4 energy, and I chose the gamma radiation, and there's an image behind it. So this is the wavelengths, as you can tell, and gamma's is pretty small. So the gamma radiation is high energy photons that are emitted by radioactive nuclei. Gamma rays originated in the nucleus, while X-rays originated in the electron cloud around the nucleus. So here are some properties of gamma rays. The gamma Y rays are not deflected by electric and magnetic fields. It shows that they do not have any charge. The gamma Y rays travel with the speed of light. The rest mass of a gamma Y ray photon is 0. Gamma Y rays affect a photographic plate more than B particles. And here is an image of the gamma Y ray. So there hasn't been any focusing gamma ray telescopes. Instead, astronomers rely on alternate ways to determine where in the sky gamma rays are produced. They use special masks that cast gamma rays shadows on the detector. The SWIFT satellite was launched in 2004 to help solve the mystery of the gamma ray burst. So here's an image of the Burst Alert Telescope, NASA SWIFT satellite under construction, and then here's another image of it once it's done. Alright, so here is a clip while it loads. SWIFT has a gamma ray detector that can observe half the sky at a time, and if it detects X-rays and optical telescopes in the direction of the burst. So here's a little clip of the burst. The gamma ray burst are the most energetic and luminous electromagnetic events since the Big Bang, and can release more energy in 10 seconds than our sun will in 10 billion years. Scientists can use gamma rays to determine the elements on other planets. The gamma ray spectrometer on NASA's Mars Odyssey detects and maps these signatures, just like the image showing hydrogen concentration of Martian surface soils. So as you can tell, the lower limit of water mass fraction on Mars shows it, and this is my reference.